Welcome to liveteacher.ca. This is Mr. Gupta speaking to you. We are going to do a little short lesson on simple circuitry here. I'm going to try and explain the issues of voltage, current, which is measured in amps, and resistance. And we're going to do this with the analogy of shopping. So, you're at a mall. You have a bank. You have stores. And in order for you to make this mall work appropriately, you must get money from the bank. So let's say we get $10 from the bank, and we must spend money at the stores. Now this is a closed system, so whatever money you get from the bank, you've got to spend at the store. This is equivalent to voltage. So you cannot return to the bank until you are completely broke. So $10 came out of the bank, you went around the mall, spent it all at the store, and you come back with zero. That is the purpose of a bank. Now, in malls you also have shoppers. These are the people. So let's say we had 5 shoppers here. Well, if there are 5 shoppers that go through the bank, then there must be 5 shoppers that go through the store before they return to the bank. This is the same as current. So watch this. We're going to go to our next screen. Here is what we know in our circuit diagrams. This is a battery or a cell. This is a store. In this case, it's a light bulb. So if we are a bank here, and a store here, then what that means is when I come in with no money, I get whatever the voltage is when I leave here. So if this is 3 volts, if that's equal to 3 volts, then that means I get 3 volts out of this bank when I left here. Then I have to spend that money, that voltage, at the store. So that means the store has a voltage of 3 volts as well. And I've got 0 when I come back and 3 volts when I get in. Now, as far as shoppers are concerned, let's say I had 10 shoppers. If I had 10 shoppers, that means I have 10 amps as far as current is concerned. If I have 10 shoppers coming through the battery, that means I'm going to have the same number of shoppers going through the bulb. So therefore, I have 10 amps there. Now, there's this law called Ohm's law. Ohm's law says V equals I times R. Now, I've got V, I've got I, which is your current, but I don't have R. So how do I figure that out? R is equal to V divided by I. So in this case, way up here at the battery, it's 3 volts divided by 10 amps is equal to 0.3 ohms. That is my resistance. And down here, guess what? It's going to be the exact same. Now you're thinking to yourself, wow, that looks like the same numbers everywhere. But how that comes into play is when you talk about series and parallel circuits. Watch this. If you can imagine one store after another before you return to the bank. These are light bulbs, of course. There's my bank. If I was given, or if I took out 100 volts here, and I only spent 60 volts here, how many volts would I have left here, Mr. Knowlton? Any ideas? Right, that would be 40. So that means that bulb here is 40 volts. Now, let's go to our current. If I had let's say 10 shoppers here at the battery, how many would I have going through this bulb? I'd still have 10 because the same shoppers have to follow that path. And how many would I have at this bulb? Again, the same shoppers would have to go through there. So that means I've got 10 shoppers all the way around in this series circuit. Now when I do my resistance calculations, again, V divided by I is equal to R. 100 volts divided by 10 amps, that means this has 10 ohms resistance at the battery. Here we only have 6 ohms resistance, and here we have 4 ohms resistance. Now, one last example. If I do a parallel circuit, it's a little different, but it's the same principle. Now we've got a shopping mall with more than one branch of hallways. So if I had 100 volts here, when I leave with 100 volts here and I come down here and I have to make a decision, I'm going to go right, then I've got to spend 100 volts at that one. Now when I leave that store, I can only return back to the bank to collect the money again. If I come out of the bank with 100 volts again and I go through this branch, well, I'm still spending 100 volts at that store. And when I return, I can't go against traffic, so I got to keep going up to the bank again, plus I'm empty-handed anyway. Then when I look at the number of shoppers, if I had, again, 10 shoppers here, When I come through here, 2 might go this way. Let's just say 2 do. So how many go through this branch? Mr. Knowlton, any idea? If I have 2 going this way, and how many do I have left? I've got 8. That is correct. So when I've done that and figured out how much money I spend at each store and how many people are going through each branch, I can again do my Ohm's law calculation, and I'd get 10 ohms here. I'd get 50 ohms here. And 100 divided by 8, good grief. Someone pull out the calculator. Go to our accessories calculator. 100 divided by 8 equals 12.5 ohms there. Resistance, resistance, resistance. 3 branches, parallel circuit, all based on shopping. Have a good day.